Good morning, students. So far, we have derived the equation of the tangent and normal at the Cartesian point and the equation of the normal at the parametric point. And we have solved some examples prior to this exercise. So, before we move on to the exercise, let us first write all the formula at one place and then we will start the exercise. First, the equation of the tangent at the Cartesian point px1 y1 to the ellipse s x square by a square plus y square by b square minus 1 equals to 0 is s1 equals to 0. And what is the notation of this s1? xx1, that is xx1 by a square plus y1 by b square minus 1 equals to 0. The equation of the normal at the parametric point x1, y1 to the ellipse s is equals to 0 to the ellipse s equals to 0 is a square x by x1 minus b square y by y1 is equals to a square minus b square. So these two are tangents or normal at the Cartesian point P x1 y1. Now the equation of the tangent at the parametric point. What is the parametric point of the ellipse? A cos theta, b sin theta to the ellipse s equals to 0 is x by a cos theta plus y by b sin theta is equals to 1. The equation of the normal at the parametric point at p theta, the parametric point is denoted as p theta, that is a cos theta b sin theta to the ellipse s equals to 0 is a x by cos theta minus b y by sin theta is equals to a square minus b square. And the slope form of the tangent is the slope form of the tangent, that is the equation of the tangent in the slope form is y is equals to mx plus or minus square root of a square m square plus b square. So then y is equals to mx plus c. In the place of c, we have got this, and this is the condition that the line y is equals to mx plus c to be a tangent to the ellipse. The condition that the line y is equals to mx plus c to be a tangent to the ellipse s equals to 0 is c square equals to a square m square plus b square, and the point of contact is minus a square m by c comma b square by c. This we have discussed before. And the condition that the line lx plus my plus n equals to 0 to be a tangent to the ellipse is a square l square plus b square n square equals to n square, and the point of contact is equals to minus a square l by n minus b square m by n. So these are the crucial points to solve the exercise 4b. So the first question from the exercise 4b, find the equation of the tangent and normal to the ellipse x square plus 8y square equals to 33 at minus 1 comma 2. So given ellipse is x square plus 8y square is equals to 33, and given point is p x1 y1 is equals to minus 1 comma 2. Now equation of the tangent at p x1 y1 to the ellipse, let us suppose this be S. Ellipse S equals to 0 is S1 equals to 0. So what is the notation of S1 for this? X1 plus 8 into y1 minus 33 equals to 0. So x1 y1 point is minus 1 comma 2. Substitute. So x into minus 1 plus 8 y into y1 value is 2 minus 33 equals to 0. This is minus x plus 8 to the 16y minus 33 equals to 0. Therefore, the equation of the required tangent, the equation of the required tangent is x minus 16y plus 33 equals to 0. I have taken minus in common, and this is the equation of the tangent. And the equation of the normal is, no need to use the formula a square x by x1 minus b square by y1 equals to a square minus b square. So this can be written as x square by 33 plus y square by 33 by 8 equals to 1 and all. So, but normal is perpendicular to the tangent. What is the perpendicular equation of this? So now equation of normal. So the line which is perpendicular to this x minus 16y plus 33 equals to 0 is, so the quotient of x is 1 and quotient of y is 16. So this will be 16x plus 1y plus k equals to 0. So because ax plus by plus c equals to 0, the line which is parallel to this is ax plus by plus k equals to 0, and the line which is perpendicular to this is bx minus ay plus k equals to 0. That means in between ax and by plus is there, change the sign, and this x coefficient and y coefficient will be interchanged. So same I have written here also. Now Since so this is the ellipse and this is the tangent that we have found earlier, and this is the normal. Normal is perpendicular to this tangent and passing through this point of contact of a line and the ellipse. This is P. And this Px1 y1 is equals to minus 1 comma 2. Since this line is passing through minus 1 comma 2, so substitute 16 into minus 1 is minus 16 plus y is 2, 1 into y is 2 plus k equals to 0. So from this k is equals to minus 16 plus 2 is minus 14. If you transpose onto another side, that is plus 14. Therefore, the equation of the required normal is, so replace k with the 14 here, then we'll get 16x plus y plus 14 is equals to 0. And this is the equation of this normal. Now the question is, find the equation of the tangent and normal to the ellipse x square plus 2y square minus 4x plus 12y plus 14 equals to 0 at 2 comma minus 1. The same problem, but the numbers are differed. And one more thing that we have noticed here is, earlier that is the ellipse in the standard form whose center is at the origin, but here the center is not at the origin, shifting of the origin taken place. So, but the concept is same. Let the given ellipse be S x square plus 2y square minus 4x plus 12y plus 14 is equals to 0. So given point is, let the given point be, I'll take P, which is x1 y1 equals to 2 comma minus 1. So equation of the tangent at P x1 y1 to the ellipse s equals to 0 is s1 equals to 0. So the notation of s1 for this ellipse is xx1 plus 2 into y1 minus the quotient of x is 4, half of it. So 2 into x plus x1 plus the coefficient of y is 12 by 2, which is 6 into y plus y1 plus 14 equals to 0. So this is equals to x1 y1 being 2 comma minus 1. So x into 2, 2x plus 2 into y1. Y into y1 is minus 1. Minus 2 into x plus 2 plus 6 into y1 is minus 1 plus 14 equals to 0. So this is equals to 2x plus into minus minus 2y minus 2x minus into plus minus 2 2s are 4 plus 6 into y 6y plus into minus minus 6 1s are 6 plus 14 equals to 0. So 2x gets cancelled. So 6y minus 2y is 4y. Minus 6 minus 4 minus 10. Minus 10 plus 14 is 4 equals to 0. So if you take 4 in common and cancel toward the equation, therefore the equation of the required tangent is y plus 1 equals to 0. To be more specific, this y can be written as 0x plus 1y plus 1 equals to 0. So this is the tangent and we require normal also. It is obvious that normal is perpendicular to the tangent. So what is the line which is perpendicular to this? So the line which is perpendicular to this y plus 1 equals to 0 is of the form y plus 1 means this. So in between plus is there, replace with minus, and y quotient 1 is shifted to x, and x quotient 0 is shifted to y, 0y plus k equals to 0. Therefore this is x plus k equals to 0. And this normal is passing through 2 comma minus 1, which we have seen before also. Since it is passing through 2 comma minus 1, substitute 2, y is absent, plus k equals to 0. From this k is equals to minus 2. Therefore, the equation of the required normal is x minus 2 equals to 0. Find the equation of the tangents to 9x square plus 16y square equals to 144, which makes equal intercept on the coordinate axis. So that means this is the ellipse. So this is the tangent. So this is the tangent to this ellipse. Now, this being the center, positive x-axis, negative x-axis, positive y-axis, negative y-axis. And so this line where it cuts the x-axis is, suppose this is A, and this line cuts y-axis at B. So what is that is given is which makes equal intercept. That means this line is making equal intercepts on the coordinate axis. That means this and this are equal, that is given. So let us suppose that this A and this is also A. So since this is the line in the intercept form, x by A plus y by B equals to 1. So x by A, y by B is also A. So x by A plus y by A equals to 1. LCM if you take x plus y by A equals to 1, x plus y equals to A. That is this line. So given equation of the ellipse is 9x square plus 16y square equals to 144. So that implies divide with 144 on both the sides, then we'll get 9x square by 144 plus 16y square by 144 equals to 1. This implies x square by 9 by 144 16 times plus y square by 16 times 144 by 9 equals to 1. So here a square equals to 16, which is a equals to 4, and b square equals to 9. From this b is equals to 3 A is greater than B. So therefore, the x-axis is the major axis. Now, so since the line makes equal intercepts with the coordinate axis, implies the equation of this line is x by a plus y by a equals to 1, implies x plus y is equals to a. So, what is the condition for this line is a tangent to the ellipse? The condition for the line x plus y equals to a to be a tangent to the ellipse x square by 16 plus y square by 9 equals to 1 is c square equals to a square m square plus b square. So from this is ax plus by plus c equals to 0 or minus a equals to 0 plus c equals to 0. And this is otherwise. So a square m square plus b square. So from this is equals to a. From this y is equals to minus x plus a. So this is the form y is equals to mx plus c. So m is equals to minus 1. C is equals to a. So c square is how much? A square is equals to a square is 16. M square is minus 1 whole square plus b square is 9. So minus 1 whole square is 1. 1 into 16, 16, 16 plus 9, 25. So a square equals to 25. Therefore, a is equals to plus or minus 5. So substituting this plus or minus 5 in this equation, we will get the equation of a required tangent. Therefore, substituting a is equals to plus or minus 5 in, let us suppose that this is the first equation. In 1, we will get x plus y is equals to plus or minus 5. So here equation of the tangents is mentioned. That means the tangent is not one, plural sense, more than one. So x plus y is equals to 5 is one line and x plus y is equals to minus 5 is another straight line. That means it may be like this also. So this is A and this is also A. So there is a possibility of another line here according to the diagram. That is why we have got two equation of the tangents. Find the coordinates of the points on the ellipse x square plus 3y square equals to 37 at which the normal is parallel to the line 6x minus 5y equals to 2. So what the question says is coordinates of the points on the ellipse. So let us suppose that this is our ellipse. So at which the normal mention is there. That means let us suppose that this is the tangent first of all. So first of all this is the tangent and this is the point of contact of this line and the ellipse. So the line which is passing through this point of contact and perpendicular to this tangent is this, and that is the normal. So according to the question, so at which the normal is parallel to the line, this normal this normal is parallel to this normal is parallel to the line. This is what? 6x minus 5y minus 2 equals to 0. So if this is a normal, if you extend this, then this normal and this tangent are perpendicular to each other. So if this is the normal, then is it possible for us to find out the equation of this tangent? Why not? Because if it is ax plus by plus c equals to 0, then this is bx minus ay plus k equals to 0. So the equation of the given ellipse is x square plus 3y square equals to 37. So that implies x square plus 3y square by 37 equals to 1. This implies x square by 37 plus 3y square by 37. This is y square by 37 by 3 equals to 1. So a square equals to 37 and b square equals to 37 by 3. So given line is 6x minus 5y minus 2 is equals to 0. So what is this line? This line is parallel to this normal. So this line is parallel to this normal. So then what is the line which is perpendicular to this line? Which is the tangent. So the line which is perpendicular to 6x minus 5y minus 2 equals to 0 is of the form 6 and 5 are interchanged. So in between minus is there. Replace it with plus and plus k equals to 0. So this is 5x plus 6y plus k equals to 0. So what is this 5x plus 6y plus k equals to 0? That is this 5x plus 6y plus k equals to 0. That is the equation of the required tangent. Since this tangent touches the parabola, touches the ellipse, so the condition is, what is the condition for the line? For the line, if we convert this line into y is equals to mx plus c, then the condition used is c square equals to a square m square plus b square. But if you are not interested to convert this into y is equals to mx plus c, then this is of the form lx plus my plus n equals to 0. And what is the condition for the line lx plus my plus n equals to 0 to be the tangent to the ellipse x square by a square plus y square by b square equals to 1, which is a square l square plus b square m square equals to n square. I am telling you, in both the ways you can do it. So if you leave this as it is, then it has become lx plus my plus n equals to 0. The condition used is this. Otherwise, if this can be written as 6y is equals to minus 5x minus k. So, and y is equals to this, with 6 you divide, then we get y is equals to mx plus c. Then the condition used is c square equals to a square m square plus b square. That is your choice. Now, here a square is equals to 37. L square, L is 5. So 5 square is 25 plus b square is 37 by 3 into m square, m is 6. M is 6 square 36 is equals to n square n here is this k square. So 3 12s 36. 37 25s, 37 12s. So 37 if you take common, 12 plus 25, 37. So 37 37s. This is k square equals to 37 37s is this, or 37 square. Therefore k is equals to 37 we get, plus or minus 37. So then what is the point of contact? Find the coordinates. That means we need to find out this point of contact. So the points are minus a square L by n minus b square m by n. So if you take n, and what is this n here? And what is this k here? This is plus or minus 37. That means this is 5x plus 6y plus or minus k is equals to 37 equals to 0. Then here ax plus by plus c equals lx plus my plus n equals to 0. N here is plus or minus 37. Now substitute. If n equals to plus 37 if you take, and substitute here, minus a square is 37, L is 5 by n is 37, comma, minus b square is, this is b square is how much? 37 by 3. 37 by 3 into m value is 6 by n value is 37. That means 37 gets cancelled. 3 2s are 6. So I'm rubbing this. Then this is equals to, this is minus 5 comma, this is minus 37 into 2 by 37. 37 gets cancelled. So we left with the minus 2 here. So, and if n is equals to, second case also we have to take into consideration, which is minus 37. So minus 37 and substitute here. So minus 37 into 5 by minus 37. So minus 37 by 3 into 6 by minus 37. So minus 37 gets cancelled. 3 2s are 6. Minus 37 gets cancelled. We get 5 comma 2. So this is 5 comma 2, and there is a possibility of another point also. So that is 5 comma 2. Find the value of k if 4x plus 5y plus k equals to 0 is the tangent to the ellipse x square plus 3y square equals to 3. Given equation of the ellipse is x square plus 3y square equals to 3. So if we divide with the 3, then this is x square by 3. 3y square by 3 is y square by 1 equals to 1. Dividing with 3 on both sides. So given equation of the line is 4x plus y plus k equals to 0. So if you compare this with the line Lx plus My plus n equals to 0, then this is L equals to 4, M equals to 1, N equals to K. So since this line is a tangent to this ellipse, since the line is a tangent means touches the ellipse. What is the condition for the line Lx plus My plus n equals to 0 to be a tangent to the ellipse x square by a square plus y square by b square equals to 1, which is a square L square plus b square m square equals to n square. So a square here is 3, b square equals to 1. So 3 into L square is 4 square 16 plus b square is 1 into m square is 1 square is equals to n square is here k square. So 316 is 48 plus 1 49. So k square equals to 49. Therefore k is equals to plus or minus 7. So he is asking us to find the value of k. Therefore k is equals to plus or minus 7. Find the condition for the line x cos alpha plus y sin alpha equals to p to be a tangent to the ellipse. Given equation of the ellipse is x square by a square plus y square by b square equals to 1. Given equation of a line x cos alpha plus y sin alpha equals to p. So here this is of the form a lx plus my plus n equals to 0. Here l equals to cos alpha, m equals to sin alpha, n equals to minus p. So the condition for the tangent for the line Lx plus My plus n equals to 0 to be a tangent to the ellipse x square by a square plus y square by b square equals to 1 is a square L square plus b square m square equals to n square. So a square and b square are same because this is the standard form of the ellipse. So a square L is cos alpha whole square, cos square alpha, plus b square is b square itself, and m square is sin square alpha is equals to n value is minus p with whole square is p square. Therefore this is the required condition. So before we wind up this today's class, so before first and second problems, let us solve this. This is the third problem from the second problem. Find the equation of the tangents to the ellipse which are parallel to this line, perpendicular to this line, and makes an angle alpha with the x-axis. Alpha is find for here. Since parallel, perpendicular, and angle is given, so we have to proceed this through the slope, because line is given, ax plus by plus c equals to 0, line is given, the slope is, we can get the slope. So if slope we are getting, then what is the equation of the tangent in the slope form? Slope form of the tangent y is equals to mx plus or minus square root of a square m square plus b square. So with that we can easily find it. So this is given equation of the ellipse is 2x square plus y square equals to 8. So x square with the 8, if you divide 2x square plus y square by 8, so 2 by 8, this is by 4 plus y square by 8 equals to 1. A square equals to 4, B square equals to 8. So now, first one, given equation of a line is x minus 2y minus 4 equals to 0. So, the parallel to this. So, what is the slope of this? Slope of this is m equals to minus a by b minus coefficient of x by coefficient of y. So, this is minus 1 by minus 2 minus a by b x coefficient by y coefficient minus 2 minus of minus gets cancelled 1 by 2. So here this line slope is 1 by 2, and what is the line which is what is the slope of a line which is parallel to this? Same, because this is the line x minus 2y minus 4 equals to 0, and the line which is parallel to this is this. So both are parallel to each other. The slopes are going to be same. So the slope of a line which is parallel to x minus 2y minus 4 is equals to 0 is also the same, m equals to 1 by 2. Therefore, slope form of the tangent is y is equals to mx plus or minus square root of a square m square plus b square. So this implies y is equals to mx, m is 1 by 2, x plus or minus square root of a square is 4, m square is 1 by 2 whole square 1 by 4 plus b square is 8. So 4 gets cancelled. Y is equals to 1 by 2x plus or minus. So 1 plus 8, 9. Root 9 is 3. So this is, if you find the LCM 2 here, then this is x plus or minus 2 3 is 6 is equals to y. Therefore, x, this is 2y, if you take to the side, minus 2y plus or minus 6 equals to 0 is the equation of the tangent parallel to this. And the second one is, so given line is x plus y plus 2 equals to 0. Its slope m equals to how much? Minus a by b minus 1 by 1, so minus 1. But here perpendicular to the given line is this. This is the x plus y plus 2 equals to 0 line, and what is the line which is perpendicular to this will be this. So the slope of this is minus 1, and what is the slope of this? It is 1, because product of the slopes is equals to minus 1. So slope of a line perpendicular to x plus y plus 2 equals to 0 is m equals to 1. So this is equals to y is equals to mx. So 1x plus or minus square root of a square m square. A square is 4, m square is 1, m is 1 here. A square m square plus b square is 8. So y is equals to x plus or minus 8 plus 4, 12. Root 12 is 2 root 3. So therefore, x minus y plus or minus 2 root 3 equals to 0. And the third question is, makes an angle pi by 4 with the x-axis. So that means it is, for example, this tangent and this tangent, this is the ellipse, for example, and this line touches this ellipse. So, and this line is making an angle pi by 4 with the x-axis. Therefore, so if the line is making an angle pi by 4, that means slope m equals to tan theta. So tan theta is here pi by 4. Tan 45 is 1. So the same we are getting this. Therefore, the equation of the required tangent is same. Here earlier m equals to 1, here also m equals to 1. Therefore, the same line is what we are going to get. So x minus y plus or minus 2 root 3 equals to 0.